Hello, all. My name is Danny Doyle. I'm with Safety Components. I am the PPE consultant for the Northeast. Leading into 2021, we wanted to start a new project and deliver training clips via Zoom with some great instructors that are known across the country, good friends. We have quite the list that we're going to get in contact with, and hopefully they'll be willing to join us. But these training clips are going to be anywhere from 5 to 10 to 15 minutes long. We're just a little snippet of your time so that you can pick up a great street proven fireground tip. And then, morph that into the training ground and onto your fireground. And we'll talk about that here in a second also. But today we have Sammy Hiddle joining us, a very close friend of mine and a captain in the Wichita Fire Department. And he's going to give us a little PowerPoint presentation. These training clips are going to be everything from kitchen table banter in a firehouse, good conversation, maybe even about some firehouse culture or an instructor interview, if you will, all the way to maybe a few slides in a PowerPoint and a street smart tip. So I think it's going to be a really good thing, and we're going to try to put out one a month on average. So I'm hoping everything takes off and it's well received. So a little bit about Sammy and Wichita. So the Wichita Fire Department covers for a population of 400,000 with 22 firehouses. They have 450 firefighters, give or take, uniformed, and they do that with 21 engines, 5 trucks, and 2 heavy rescues. Sammy is a captain on the newly added Heavy Rescue 2. Sammy, like I said, he's been a longtime friend. We've taught side by side for quite a while, and we have a lot of stories that go along with it. We've been humbled to be able to travel across the country and have a good time together, meeting other people, and preaching a craft, if you will. We teach together in traditions training. We've served together on the UL Fire Attack panel, and we also have taught for the better part of 10 years together at FDIC with Mike Champo and the Truck Company Essentials Group. So with that, Captain Hiddle, take it away, my friend.
I appreciate the opportunity to get to help unroll this. Like we've talked about a lot of times, Safety Components it's a good company. We've been wearing their gear in Wichita or being protected by them in Wichita my entire career, and they've supported the smaller conferences. They support the big conference. So to see them continue to do this, I'm not surprised. What we're going to do today is we're going to talk about ladders, but we're going to look at it in a little different way. Instead of just looking at throwing ladders, we're going to look at it as a lever and why we're successful and why we fail.
Okay, so let's get started.
Excellent.
When we look at our ladder raising success, it comes down to a lot of different variables and how they interrelate with one another or work in concert with one another. We're looking at what type of fulcrum we're operating on, the angles we're dealing with, and then how we're positioned in relation to the center of mass of the ladder itself.
Most of the time when we're throwing a ladder, we're operating in a class 2 lever situation where the butt of the ladder is on the ground or wedged up against the building, our resistance is in the middle, and our effort's on the other end at the tip of the ladder, and we simply push. Now, in those situations where we cross the center of mass and the ladder gets heavier behind us than it is in front of us and causes the butt to lift up, we're trying to throw it on a smooth or slick surface like concrete. Then what happens is we transition into a class 1 lever. When we transition into this new lever type, the fulcrum also transitions and now will rest on us. The resistance will fall behind us, which means the effort now goes in front of us. This is why it's important for us to be aware of where we're at in relationship to the center of mass of the ladder. Because when we cross that center line and get more weight behind us, we increase the potential for the butt of the ladder to raise up. We go from that class 2 to that class 1 lever. When that happens, we have to make a mental transition along with it and change our type of effort. We're no longer going to push, and now we're going to start to pull because that effort has to happen out in front of us. The other thing that's going to happen is we're going to start operating with a negative mechanical advantage. We see this mostly when we go from 14-foot or 16-foot single ladders to 18s and 20s.
It's not the weight of the ladder that gives us problems. It's failure to recognize that we've gone to a different type of lever, failure to change our effort type, and failure to recognize that our effort's going to have to be increased because we're operating with that negative mechanical advantage now. So think of the negative mechanical advantage kind of like this. If we're operating in this class 2 lever here, where the fulcrum's on the ground, and I lift the ladder at the end, I'm not going to have any trouble. However, if I were to move my hands towards the bottom of the ladder and try to raise it, assuming that the butt of the ladder stayed on the ground, it would be incredibly difficult, if possible at all. So now let's start combining some of these things. And for the purpose of the discussion, we're going to operate with a 2-section 35-foot ladder. It's 20-foot bedded, 122 pounds. This being a duo safety, it's what we use as a department, and so that's what I'm familiar with. Our firefighter is going to be average height male, 5 foot 9.5 inches, and we're going to position this firefighter 2/3 along the ladder. This is where understanding where our fulcrum is, and then also angles, which we'll discuss a little bit later in the program, start to matter. Because you can see, even though they've crossed the center of mass, because the butt of the ladder is stationary on the ground and acting as the fulcrum, it only requires 98 pounds of effort to continue to raise this ladder. However, if the butt of the ladder comes up off the ground for some reason and we transition into that class 1 lever, now we've got to reach out in front of us and start pulling. But we're operating at a negative mechanical advantage because we have much more weight behind us than what's in front of us. You can see in this illustration that reaching out 1.5 feet in front of us requires 341 pounds for a ladder that only weighs 122 pounds. If we're able to reach out just 6 inches more, then we can reduce the amount of effort required to 256 pounds. But that's still significant because we're operating in a negative mechanical advantage situation. And that's absent the shock load of regaining control of it as the tip of the ladder starts to drive itself towards the ground and the butt of the ladder towards the sky. Now let's take a look at how angles affect how we raise the ladder or the amount of effort required. I typically look at the trouble zone of a ladder between 30 and 60 degrees, knowing that at the 45-degree mark, I'm going to encounter the most significant amount of effort required to make this happen. This being a class 2 lever, of course. For this illustration, we're going to be using a 2-section 24-foot ladder, which is 14-foot bedded and 72 pounds, and again, using an average height male. So you can see at 30 degrees, it requires 38 pounds of effort to raise. When we get to the 45 degrees, it's 44 pounds, and as we transition into the 60 degree, we go back to 38 pounds. And of course, we know that if we continue to raise this ladder as we get to a 90-degree angle, all of that weight is going to transition into the ground and won't require any effort at all to continue to raise it. So what is the significance of the angle of the ladder when we relate it to the center of mass? What we're going to look at is some different angles. Now you'll see a tick mark at the ground level for each illustration. This represents the same distance from the butt of the ladder. Now you can see at 30 degrees how far beyond the center of mass we are, and we know that this encourages the ladder to go to that class 1 lever, which gives us more trouble. At 45 degrees, it's not nearly as significant, but as soon as we get to that 60-degree angle, you can see how we're almost in line with the center of mass, which keeps us in a favorable position to raise that ladder. This is why shorter people and females typically have a more difficult time raising longer ladders. It's not that our female firefighters are weaker, it's just they're generally shorter, being an average height of 5 foot 3.75 inches. Which means if we keep this ladder at the same angle, you can see how a taller person is going to operate on the advantageous side or the right side of the center of mass much longer, giving them a lot less problems than the shorter person who crosses that center line. If our goal is to get to a favorable angle quicker, one of the things we can consider is how we carry or throw the ladder. If we do a low shoulder throw, not only do we have to work through the entire trouble zone of 30 to 60 degrees, but we also lose our momentum. If we do a high shoulder throw, then we can take advantage of the potential momentum, assuming that the butt of the ladder will stick in the ground. Something else we can do to increase the angle is push up on the ladder, increasing the height where the effort occurs. When doing this, I personally find it beneficial to kind of pull back with my lower hand to help balance the ladder. Another thing we can do is choke up on the ladder. What this does is shorten the distance between the end of the ladder and where our effort is. So when we plant the butt of the ladder into the ground and turn it into our fulcrum for the lever, we see a shortened distance between the butt of the ladder and our feet, ultimately resulting in a more favorable angle. You can see that if the average height firefighter chokes up just 1 foot on a 24-foot ladder, they're going to have 40% less effort required of them to raise it once the downward momentum begins. Instead of choking up, another thing we can do is use tools to front load the ladder. This ultimately shifts the center of mass of the ladder closer to the feet, giving us the same result of shortening the distance between that and where our effort occurs. A side effect, like everything else, we gain something, we lose something, we are going to add increased weight to carrying the ladder. Another area we tend to see firefighters get in trouble is when they fail to realize that their circumstances are cheating them. Take, for instance, throwing a ladder on uneven terrain. If the butt of the ladder is being planted at the same grade that my feet are on, I'm going to be in a more advantageous position to throw that ladder. However, if the butt of the ladder is on a higher grade, you can see how I'm more likely to cross that center of mass of the ladder while at an unfavorable angle, increasing the difficulty of making that happen. That's why, if possible, we want to put the butt of the ladder on the same grade that our feet are operating at. So let's take a look at this in action. Simple high shoulder carry, where momentum's used to help transition us through the trouble zone. This one is going to show a high shoulder carry with choking up while simultaneously increasing the height at which the effort occurs to get our favorable angle. This next video demonstrates the benefit of front loading a ladder with tools to shorten the distance between the butt of the ladder and where our effort occurs. You're going to notice it requires less hand movement and it doesn't rely on momentum to get that favorable angle that we desire. So finally, let's take a look at throwing the 35 foot by yourself. It's not something that's ideal, it's certainly not something that's enjoyable, but it's something that we might have to do. So we need to know how to do it, or even if we're capable of doing it. The first part of this video is going to show a 3-section 35 beam raise on concrete. You're going to notice that I try to immediately choke up on the ladder, but when that doesn't work and I start to notice that the butt of the ladder is sliding, I choke up more, I position my hands even further down and go only into pulling it. The next part of this video shows utilizing a tool to keep the butt of the ladder on the ground so I can raise it the entire time as a Class 2 lever, pushing only instead of changing how I apply my effort. So the very last thing we want to show you is this. This is just utilizing a tool in concrete to try to maintain a Class 2 lever by holding the butt of the ladder on the ground. The biggest difference you're going to see here though is we've now gone to a 2-section ladder. So instead of being 15-foot bedded, we're 20-foot bedded, which means I'm going to cross the center of gravity much sooner at an unfavorable angle. The other thing you're going to notice is right here, when I get to about that 45-degree angle, that's where I see the most amount of effort required to continue to raise this ladder. If we can, we want to use momentum to our advantage. This is one of the benefits of the high shoulder carry, like we discussed earlier. By keeping the momentum of the ladder moving forward as we plant it into the ground, we reduce the amount of effort over time, making the raise easier. So what do we pick? a 2-section 35-foot ladder or a 3-section 35-foot ladder? Honestly, it doesn't matter as long as you take certain things into consideration and understand that while you gain something with one, you lose something with another. For instance, raising a 3-section ladder is much easier than a 2-section because the 3-section ladder is 15-foot bedded and the 2-section is 20. The average height firefighter remains on the right side or advantageous side of the center of mass of that ladder much longer since it is shorter. When we consider the weight difference for us who use duo safety, the difference between 122 pounds for a 2-section and 129 for a 3-section is negligible, but it should be considered depending on the type of ladders that you're choosing. What about the effort to hoist? So a 2-section, we're raising 1 section or 50% of the ladder. A 3-section, we're raising 2 sections or 66% of the ladder. Now that 16% difference between the two doesn't seem that significant until we consider the real problem with hoisting the ladder. And that's the friction in the rails that comes from not adequately cleaning our ladders. So when we look at it from that perspective, then we're almost doubling the amount of resistance that we encounter. Then we look at the halyard system itself. The 3-section has a 4-to-1 mechanical advantage. This seems like it would be beneficial to us until we consider the fact that we're likely to be tired by the time we drag this ladder over to the Charlie side, and now we have to move 4 foot of rope to get 1 foot of raise. Another consideration should be how much space you have available in your tunnel, because we can get a 2-section 35 plus a single ladder in the same space that we put a 3-section 35. This decision is something that needs to be weighed against your staffing though, because we know that if individuals are going to have to throw a 35 by themselves, that 2-section is going to be far more difficult than the 3-section. Okay, let's wrap this thing up. The last thing we want to discuss is the Class 3 lever. We're going to encounter this when we're trying to assist on a 2-person raise of the ladder. So the question is this: what is better, helping them flat raise it or helping them beam raise it? And the answer is beam raise. When we try to assist with a flat raise, we see approximately a 7-to-1 negative mechanical advantage. When we assist by doing a beam raise, we cut that down to about 3.7. So basically we're providing about 100% more assistance to raising that ladder. One of the things that we like to do in our truck academy to illustrate this is take a 14-foot single, lay it on the ground, and show them that we can't get the tip of the ladder off the ground by trying to flat raise. But if we do a beam raise assistance by ourselves, we're able to raise the ladder. The other benefit to doing a beam raise is we now have 2 firefighters facing the building. Hopefully everyone that stayed with us this long benefited in some way. We got to keep in mind, it's important that we understand why we're doing things and how we're doing them. You know, anyone can throw a ladder, first alarm of the day with just want to. It's that 3rd, 4th alarm when we're fortunate enough to have those days where we get to do that, the injuries and just getting older, where understanding how to be efficient and purposeful with the ladder is going to make the biggest difference.
Couldn't agree with you more, Sammy. And I love watching your presentations all the time. You are a huge numbers guy, and it makes sense. You're able to translate it, something that would be complicated to otherwise understand or see if it was being written on a chalkboard, and you simplify it so that we can all pick it up and actually see how things are going. And hopefully this translates. This is kind of a pet peeve of ours. We've talked about it all the time, but training clips or social media in general. And I want to put this out there, and I'm going to mention it in each video that we do so that everyone stays cognizant. The job that we do is a very hands-on job. And if you're not used to doing a specific tactic or a specific, whether it be conventional forcible entry or throwing a ground ladder or, deploying a hose line, flowing a nozzle, whatever it is, if you're not getting your hands dirty doing it in training, you're not going to be all that successful on the fire ground. So these training clips, whether it's 2 or 10 or 15 minutes, it doesn't make a difference. You have to take that training clip, watch it on your phone, and do it in a parking lot behind a firehouse, maneuver in between cars, whatever that takes. Translate it to the training and ground, please, so that way whenever you execute it on the fire ground, everyone's on the same page and you'll be good at it. But lastly, something you mentioned, Sammy, about you wear PBI Max in Wichita. I do as well in Pittsburgh on my job. I have for the better part of 10 years now. We were one of the first companies or first departments that tested it when it was hitting the market. And I was honored and humbled when I was invited to join the safety components team because I believe in the product. And I think that that's very important whenever you're invested in a team and doing things. So Sam, thank you for your time. And thank all of you for watching the video clip. We'll be back next month with another one, and hopefully another one after that, another one after that. We're looking forward to a good time. So we'll see you soon. Take care, bud.